continuing with our security theme. The next is managing passwords, and there is lots of discussion about what's a good password, what's not a good password, and the experts seem to change their minds on a semi-regular basis, but maybe it's just what it seems like to me. But we generally are going to have some basic rules or basic thoughts about what a good password is. We're going to have different policies that we're going to create, and what I want to do here is to show you a website when you have to write, and you may already know about these guys, SANS.org and Information Security Policies. These guys have templates for just about any policy that you want to write. Clean desk policy, communications, and then we can keep going on and on and on and on and on. And let's jump in here. I bet they have a password in here, password protection policy. And I wonder if they just have a general password. Password construction guidelines. What are we going to do with that? Let's just take a quick look at what it might look like. Overview, critical purpose, scope, statement of guidelines. And it contained 8 characters or less. It says poor or weak passwords have the following characteristics. 8 characters or less. Personal information such as birthdays contain number patterns such as AAA, BBB, on QWERTY, those sorts of things. Are some versions of welcome 123, password 123, change name 123 when we do those things. Passwords compliant measures. So if you get into a situation, and you will, where you have to write a policy of some type, you can get a pretty well constructed template from these guys. You go in and put your, instead of SANS, put your company on the top of it. Probably want to give them credit for it at some point, at some place on this thing, but lots of policies are available at the SANS.org, and I just had to do a search because they've kind of evolved over the course of years, and I didn't look real hard. I just went there real quick, and then it wasn't apparent then for the policies. But this is what their homepage would look like. The resources here: errors, top 25 programming errors, critical security control, security policy project. Critical vulnerabilities, affiliate director, newsletters, webcasts. There's lots of information here from a security standpoint that you may want to maintain. One of the ones that they had, and I didn't even know that they had a SANS.edu, but they do, a password policy, and this is in the student files here. That doesn't show up with links either. These are just on the search that we had. Revision history, terms and definitions, all of the things that you would expect to have in a policy. The overview, purpose, scope, the general. Let's see, this is all system level passwords, root enable, Windows administrators. Must be changed on at least a quarterly basis. That's 120 days. That may or may not be, and that's a decision that you make. May or may not be adequate for those kinds of passwords. One of the issues that I guess you don't get into anymore, that you used to get into with Windows, is you can only have a single security policy in a domain. So you might have to have multiple domains in order to have multiple security policies. You can now have security policies for each of the containers, each section. So you could have your administrators in here, and you probably, opinion, want to change them more frequently than every 120 days. We had students change them every 180 days. So what do you want to do? How often do you want them to happen? And students, we didn't feel that there was a whole lot of risk in those. All production level must be part of the InfoSec administered global password management database. User level passwords must be changed every 6 months. User accounts that have system level privileges I'm just looking at these things, the kinds of things that would be there. And then the guidelines, lowercase, uppercase numbers, punctuation, special characters that go on. Strong passwords have the following characteristics. Contain at least 15 alphanumeric characters. I'm an old guy. I'm retired. The retired pay site came up with and it was just an absolute crazy policy that they since, because us old guys have trouble doing all of those things. It was like, you couldn't have more than 3 characters, 5 characters, or whatever that existed in the previous password. You had to have so many special characters. You weren't allowed to have certain special characters. Had to be like a 22 character password. On and on and on that we would have to do. But policies, what we want to do, passphrases, and passphrases are generally used in the public-private key encryption. Passphrases are one of the things I think that they're now talking about. That helps out. What we want in these things is randomness, and I'll do the whole thing. And some of you, I think we probably talked about these, probably use a password management software. So I use this one called KeePass. And if we want to, and I've got because I can't remember all of those passwords, and you probably can't remember all of your passwords either, but what does one of theirs look like? Probably can't see that. Maybe you can see that. It's just a string of characters. It has randomness. It has no words in it. Absolutely no words in it. And if you want to create a password, we can open the password generator. We can define what we want our passwords to be. After they finally got to through doing their definitions, DFAS, I define the rules that can be used for the DFAS passwords, the place where I go. But the different ones, random MAC address, you can generate a random MAC address if you're going to spoof it to do whatever you want to do with these things. And I'm going to say that. Different things, different policies, different management of the passwords. The security policy formalized statement that defines how security will be implemented within the organization. Security policy is a high-level thing. This is what management tells us that they want, or their concept, their vision of what security is going to be in the organization. The password policy is a subset of the security policy. Sometimes, and I guess depending on how big the organization is, how detailed we want to go into these things, the security policy may include the password policy. Password policy may be separate, and we look at the SANS, at the template. Probably we want to have a separate password policy where we can specify the creating, storing, and modifying passwords, that we can specify that separately and go into a little bit more detail about passwords. They're going to be a really critical element of what we do. The length, 8 to 12 characters. The 8 characters are because, and if you've ever looked at a password cracking software, they basically split the hash in half, or split the password in half. If you have less than 8 characters, everything else is going to be padding. And all padding is the same character. So if you have fewer than the 8 characters, then it only has to crack half the password when we do that. 8 to 12 characters is going to be recommended. Complexity, a mix of letters, numbers, special characters. In the world of keyboards, we have 4 things that are available on the keyboard: uppercase letters, lowercase letters, numbers, and special characters. The complexity, at least in the Microsoft world, complexity says, complex password says that you have to have 3 of the 4, which means that something like capital P, password 1, that's a complex password. It's not a good password, but it's a complex. You kind of have to do the definitions as much as possible, help people out, and we would say we want no dictionary words, things like that. What kind of policies are we going to set? What are we going to do in order to make them good? The 30 to 90 day replacement. The one that we use, I said we use 180 days for students, which was over by double here on the maximum recommended. we didn't feel that it was a big risk with the students as long as they weren't using the same password they were using on their bank account. And that is an issue. And you probably seen the PWN pawn, PWND, I guess, site, have I been pawned? Have you been compromised? And you can go there, use your email address, and it will tell you whether that has been compromised, when it was compromised, where it was compromised, when you do those things. And that would tell me then that I need to replace the password. The problem with passwords, or issue with passwords, up, down, whatever with passwords, what we do with them is not the fact that they're never going to be compromised. If that were the case, we could use the same one forever, and we can't do that. The purpose of it and the duration and all of the other rules that we establish is so that by the time it gets compromised, it's not useful anymore. And I get these. I got an email that says that I hacked your webcam, and at the time it was the time that I had used the username and password that they sent me. I didn't have a webcam, and you did some really nasty stuff, and I want you to pay me, or I'm going to put it on your social media. Well, I don't have any social media either, but people are responding to that. One of the I help with a website, and one of the users there had an email account there sent this and said, I didn't do anything. I said, yeah, just delete the email, because it's a phishing email. Somebody's looking for money. Why do they do these things? Somebody's sending in the money. The history, and here is one of the big ones: 12 to 24 prior passwords stored, so that we don't reuse the passwords. And we really hopefully are not reusing variants of the password for those. And I'll admit I'm guilty for that, for what I call the junk accounts, the one I don't care if anybody gets into it or not. The important accounts, like my my retirement, my medical, bank accounts, those email, those sorts of things, try to use the uniqueness, unique passwords, something that generated by a KeePass or some other password manager. They will generate the randomness that we need. But 12 to 24 prior passwords are stored. Sharing and storage prohibited where possible, secure where not. And the original, the default Cisco password usage is shared, because the enable password, the enable secret password, everybody's going to use the same one. And that is one of the things that we have to overcome. We looked at local passwords yesterday, local username and password, so that everybody's got their own to be able to log into the system. If we have a shared, you don't know who's on, when, who got there, who did what, who was on, who had what authorities to do different things. But individual username and passwords, kind of a good thing with them. What I want to do is bring a Windows machine, my Windows machine over here, my virtual machine. They did the weirdness. Let's try view, and it says it is full screen. Again, it doesn't know it really doesn't know what size screen it's on. Now a little bit better, but not much. And get into this thing, and I've got the local, and you can do this on, if you're doing a Windows machine, you can configure these at home if you want. Can't make this any bigger. That didn't change the text size on it, did it? Come on, full screen, here we go. Anyhow, password policy, enforce history, and you can configure these things, and by default in the Windows world, all of these are turned off. They are not enabled when we do those. Enforce the history, how many passwords are going to be remembered? Default is 0. We can change that number. And you go into it, it explains what this is for. The default, 24 on domain controllers, 0 on standalone servers, and this is a standalone server to do these things. Maximum password age, how long can we keep the password? And explain here, every 30 to 90 days is going to be the recommendation. And I think that probably the ones that are in the slide are pretty much what Microsoft recommends. The password age, minimum password age. And this is one that's not in the list. And this is one that I think is something that you should at least consider doing. How long, minimum password long, how long do you have to keep the password after you change it? Why would I want to do that? Let's say that we had 4, for instance, for the maximum password or the remembered password. We're going to remember 4 passwords, and it's password, or my password is password, you know. So when I have to change it, I change it to password 1, and then password 2, and then password 3, and then password 4, and then I can go back to password. So yeah, it's a little bit of a pain, but I can keep the same password consistently. Minimum password age, how long do I have to keep it? I think we set ours at like 5 days. I figured that after 5 days, you probably are using the new password, and you're not going to want to go through the same process. Besides, it's going to take you 20 days to get back to the original if you keep doing the password resets, because you got to keep each one of the new ones 5 days. So when you're doing a policy, consider doing minimum password age also. When you do these things. Minimum password length, how many characters are we going to have here? Explain. The default 7 on domain controllers, 0 on standalone servers. So haven't really specified. And again, value between 1 and 14 characters. The 8 to 12 characters is recommended. The password length is the value between, and the defaults don't really do these things. Must meet a complexity requirement, is either turned on or turned off. And in this one, not contained in the user, English case, uppercase, complexity requirements are enforced when the passwords are changed or created. To do that, non-characters, and I'm just looking to see if it says that you have to, in Microsoft, you have to use enable by default. Member computers follow the configuration of their domain controllers. If we configured it on, and if we can configure it in an Active Directory policy to do these things. Stored passwords, this is a reversible encryption, and it's always disabled. I've heard all sorts of what's going to happen there. The other thing to consider when you are doing a security policy here is account lockout policy. The account duration, it's the account lockout duration, threshold, and lockout counter. The threshold here, and let's just look at this thing, is 5 invalid login attempts. I missed my username, password. I missed my password 5 times within, in this case, 30 minutes. And then the duration is how long is it going to be before it is reset automatically, so that you don't have to go and have the network administrator do the reset for you. So a number of different things that are available to you in order to manage these things. And I'll get that stretch out of the way. But the policies, these are local policies. If you want to set them on your workstation at home, you certainly can do that. Most people don't want to do that, because then you're going to be part of it also with these things. So sharing wasn't one of the things that's in there, but we really don't want to do sharing unless we absolutely positively have to. The Cisco authentication, and this is a been there, done that. The console direct or local or direct connection is going to go to the device. The local connection is pretty safe. We can also have Telnet or SSH where we do remote authentication when we do those things. I guess that we could just go ahead and look at some of these things. We have those in the privilege exec, and I guess that doing that, but these are things that we have done before. The console for all of the things that we can or can't do with them. Let me see if I can get logged in here on Packet Tracer. Do these things. Maybe not a good one, I'm not good. This thing, and I've got the slide over here. Let us, now we might as well do a router. Let's bring a router up and a workstation up. The PC, and we will, the blue here for Packet Tracer is the console, the RS-232, the serial port to the console port. And when I try to do this, I should be able to get onto the system. If I go to the desktop and then go to my terminal, and what we're going to be using for terminal is probably going to be, it's going to be one of the other systems that we have available. PuTTY, one of the things, one of the more popular ones that we use. But when I go here, I'm in, and then this is the one that's configured what it should be. I don't have any configuration. I'm going to say no, I don't want to get there. I can do everything on the system, but it didn't ask me for a password. I can go in and configure that like we did yesterday. Config T and do a local username and do let's don't do a privilege level. Well, we can do a privilege level. It's just, we won't do a privilege level. We'll just do a secret to do that. Now we have to apply it, and we go to linecon 0, the console, and use a login local. Do show run. When I go down and look at it, if I get down to it, linecon 0 login local. We talked about the VTY04. The aux here is line aux 0. We can do the same configuration with it. VTY04 is going to be by default. It's going to be our telnet. It just says login with no password. It says, hey, you're going to need one of these things. So let's do this one, and let's do a disable. To enable, you disable, and then we're going to log out. And now we need a username and password in order to get into this thing. We still have everything else available to us. But this is initially, or we can actually go into here and do a config T and do an enable secret, SECRE, secret. If I mistype it, we'd have to go do a password recovery. And now if we do a disable and do an enable, I have to do the password. This is everybody's got the same one. No real distinguishing between anybody's ability to get on and what they can do with the issue, with the device itself. So local username and passwords, privilege levels specified on creation. And let's go redo that one and do specify the privilege level. And let's do no username show run to be sure it's gone away. It is the host name. We have our MD5 hash here for secret, but the rest of it is no more. So let's do a username, and we can set a privilege level, and remember 0 to 15, and I'm going to do 15, which is the privilege exec mode, and then the password, the secret, C-R-E-T, secret, do show run, just out of curiosity, secret. And if you look at this, just to show you that the hash are the same, because we used this says it's a secret and 5 is still an MD5, secret MD5 for these things. But the password, the hashes, the two hashes, the same algorithm, the same character string, we're going to get the same hash. And that's the same hash. The birthday attack is just in case something goes on. The birthday attack is two different character strings get the same hash. It can do that if we do that. So now we do an enable, and I don't want to do an enable. I want to do a get out of it, a log out, and username, because we still have the configuration there, the username there and the password list. So you notice that it jumped me, remove it up here, directly into privilege exec mode because I set the privilege level when I created the username and password. Those are things that we can do with the situation. So all of the passwords, a number of them going on, the enable password, if we have the enable secret configured, the enable password doesn't count. So console local direction, we can use a username and password or the password only. I could have done for the console login, and then password is the password for those things. Telnet and SSH, same thing. We can do the same. What do you got to do to access the device for each of these things? Once we get into there, we can configure the privilege level, which we did. That we automatically went to 15, level 15, privilege level 15, the privilege exec mode. Or if we don't, we're going to go to privilege level 1, which is the user exec mode. Other thing that we can do and we have done it a couple of times, is to configure a radius server in order to be able to do that. And that's where we get the, we're going to get our methods list to do that. And maybe after we get back from the break, do that. We'll look at the TACACS and the privilege and the methods list again, so that maybe it makes me bring Packet Tracer if I can grab it. This has a radius server, and I'm going to probably go backwards, but we talk about the methods list. When I look at this device, this router here, and I got to log on here if I got it right. Its methods list says that it's going to use the radius server first, and I may have missed the password because I think I slipped on the keyboard. You notice it's taking a little bit of time. It does take some time to go to the radius server. It's got to do the communication, and then we've got to go through the timeout process for radius server not available, and then use I configured a local database on this. I'm going to do a show run for it, back to the authentication, login, the default, the methods list, group radius. Use the radius server first, then use the local database, and then after that, none. If you know the radius server is not available and I forgot to configure a local database, what's going to be the next one? You could use the enable or whatever you wanted to use for that. None gets us into the device, and then whatever protections we have after that is going to be okay for those things also. If and you just have to trust me on which password I used. I used the local password to get in that time. I'll go back here and enable the radius server for this thing, and we have PortFast configured because it came up immediately. And let's see if I can now use the radius server. You got to spell logout correctly. Control-Shift-6 again is the break. No IP domain lookup will stop this domain server. And this is a broadcast. I don't have one. It's trying to resolve this typo that I made to an FQDN. And now we do a username, still the same username, but pass is the password. It's now using the radius server. So the methods list, which method is it going to use for the authentication that we have. If all of those weren't available, then we should get into and that is the directory services. Here, if we have an Active Directory configured, so this is just saying that the TACACS or the radius can read the usernames and passwords from the Active Directory. If we don't have that, it can read the usernames and passwords from the radius database. We can build our own in the radius server or the TACACS server when we do those things. So these are the things that I think that we just looked at, have talked about. Local authentication, usernames and passwords are stored in the running config or the startup config file. We use the username command, username password. We can assign privilege levels there also. Remote authentication, which we just did, usernames and passwords stored on a radius or a TACACS server or as a separate directory services server. It'll interact with an LDAP, a lightweight directory access control protocol database, and Active Directory is one of those. Logging in with the password only or as a user with privilege level 1 displays the user exec prompt, the greater than. We get it, we connect to it, nothing happens. Now we don't have local authentication or remote authentication enabled on the console. We get to the user prompt, whether we have an enable secret or an enable password. When we get to privilege exec mode, privilege level 15, displays privilege exec. We may or may not have a password on that. The enable password, weak encryption, we looked at that, type 7 encryption. Enable secret password is an MD5. Message Digest 5 is the hashing algorithm that is used. for that enable secret password. If we have both configured, only the enable secret is going to work. So the things that we looked at and the summary slide here of what they are. These are just the different types of encryption that may happen. Type 0 is none, 4 is deprecated, 5 is the MD5, which we've been seeing. Type 7 is the service password encryption. Some new ones here, the Type 8 and the Type 9 with the newer iOSs, SHA-256 instead of MD5. So the 256 is going to be a much stronger configuration here. We can go in here and look at, and we'll look at secret's going to be a little bit different here, but the MD5 hash, the MD4 hash is going to be less. SHA-1 is a little bit longer, SHA-256 significantly longer, 384, 512. If we get to 512, it's going to be a pretty big hash. So the different algorithms result in different hash that we would use, and that's really what we're talking about here in these types. Password complexity, we talked about that, looked at that in the policies, in the Microsoft policies that we had. Helps protect the passwords, complex passwords, less likely to be guessed or cracked. Back to when I told you about the guy that went back to his work with the password cracking software and found out that they weren't very good. We would do things and never sometimes waited for it to actually do it, but we would have it guesstimate, and they always will estimate how long it's going to take to crack a password. If we'd put in special characters, it was significantly longer to crack passwords that had special characters in them than it were just numbers and letters, uppercase, lowercase, and numbers. Uppercase, lowercase. If you get a one and you go through and do some demonstrations, Cain Enable, which I don't think works anymore, doesn't work with Windows 10, but it had a password cracking and it had a dictionary. You could use dictionary words. Dictionary words, it just goes through the dictionary, a text file goes through there pretty fast, and it's going to find the password if we are using dictionary words. The newer password cracking softwares use a hybrid approach that they'll look at the password, find the dictionary component of it, and then use that, and then whatever's left over, they'll use a brute force to crack what goes on, what is the remaining component of it. The characters, or the parameters that we looked at, minimum password length, allowable characters, required characters, prohibitions, dictionary words, consecutive or repeated characters, all the things that were in that policy that we looked at a little earlier, things that we shouldn't allow. And it depends on the sophistication of the management software that we're using, whether we can do that or not. Last time I used Active Directory, we had minimum. Allowable characters really wasn't one of the options that was available to us. Required characters, the uppercase, lowercase, and the maybe a special character or a number, the 3 or the 4 we could. Prohibitions, dictionary words, we got a little more sophisticated that it'll tell us, hey, you've used a dictionary word, you really shouldn't do that. Consecutive or repeated characters. Alternative to passwords, multi-factor authentication. And multi-factor means that we have something from at least 2 factors, or 2-factor authentication, 2 factors, multi-factor from more than. What are the things that we have? Something we have, something we know, something we are. And now we have behavior, something you do, and maybe a location, the inheritance location. Inheritance, possession, something you have, a smart card, key fob, mobile solutions, your phone perhaps. Something you know, a username and password, a PIN number. And the PIN number can be combined with a smart card. Remember, the PIN is going to be used to encrypt the key, or hash the key, encrypt the key on the smart card. So we would have to have the smart card with the certificate on it, along with the PIN, in order to decrypt it for the encryption that goes on with it. So it would be something that we have, and something we know would be 2-factor. Biometrics, if we add a 3rd factor in, then we're going to be multi-factor. The other one over here is something you do, and I don't know where you came up with that one, but something you do would be something like your handwriting. And the handwriting is more than the shape of the characters. It can be, the pressures that you do, how fast you write, all of the things, your signature, all of the things that you do when you sign something. So we have those things. The others might be someplace that we are. When we're doing wireless, we can do geofencing. And geofencing means that we can only get authenticated if we're in certain locations. And some of you look at, and everybody looks at it, a shortcut way to get television now, because cable has gotten so much more expensive. But you look at that, or if you have looked at that, there are a number of applications that are available, a number of apps that are available. Some of them are only usable in Europe, so that would be someplace that we are. It's going to look at the IP addressing, the hierarchical structure of IP addressing. This IP address is in Germany, this one's in the US, this one's in Texas, or wherever else. So something that we are, something we have, something we know, something we do, and maybe someplace in the location that we are might be something to do. And you may have to be in certain locations. High security may be to be able to do certain things. You might have to be able to be in a secret facility in order to get onto a particular computer that has a database that only it can access a database, locally stored or something like that, to be able to do those things. Digital credentials that we have, verifiable cryptographic signatures on these things. Keep in mind that digital signatures are actually, when we get into biometrics, the biometrics have to be digitized. So the biometrics that we put so much stock in really becomes an estimation when it gets digitized to do these things. So a digital certificate, a verifiable cryptographic signature, a digital certificate. Let me get in this thing that we would see. What is a digital certificate? These are the certificates. A digital certificate that at one time identified me. This would have been, and you can see the red X here in the certification path that says that certificate's expired or is not yet valid for this. This would be the digital certificate that I would have signed emails with at one time. We have the version, the serial number, the signature, the algorithm that goes on it, signature hash, the issuer, Komodo, the validity, and you can see it is pretty old, until 2018. The subject was that email address. The public key. What does a public key look like? This is what a public key looks like. So a digital certificate, and the smart cards have these digital certificates embedded in them, and it uses the PIN number in order to encrypt this thing. So the PIN number allows us to decrypt it so that we can do that. But a verifiable cryptographic signature is a digital certificate. One-time password generated by, it says, a pseudo-random algorithm. Pseudo-random because randomness is very, very difficult to achieve. What happens with these things is we have and I think we'll get this when it comes up with a hardware token, but this would be something like to generate a one-time password, which typically is going to be a string of numbers. We're going to have this device, which obviously is synchronized with our synchronized with the authentication server, and the hardware token stores one-time password generator or certificate for this thing. So generated by a pseudo algorithm, the authentication server, Active Directory server, whatever we're using for authentication, is going to be synchronized with this thing. We'll generate a password, a one-time password, that usually is good for about a minute. And once it expires, we can generate another one, and the other end is going to be generating at the same time. It has to match, obviously, from one to the other. So the token here that we see, it's going to store the generator or the certificate that goes along with these things. We can have software tokens, the magnetic strip cards, which are not considered secure. This one has a chip on it. The chip has a certificate on it. That makes the transmission of information a little bit more secure. Smart card, cryptographic chip, contact or contactless payment. We can have the NFC, the near field communications from the phones, and keep in mind that anytime we're going to send our certificates via a wireless device, regardless of how short range it is, it actually can be intercepted. Are they secure? Yep, fairly secure. Are they absolutely secure? I don't think anything really is. We take all the precautions that we can to make it as secure as possible for us. Biometrics, the things that we are: fingerprints, voice patterns, retinal patterns, facial recognition, some hardware, keyboards or mobile phones. The keyboard, how you type, the pressures that you use on the keys, the different things that are going to be measurable. Signature would be one of the other things that we could do. Contain a biometric technology by default for these things, or some hardware contains these things, I guess what we're going for. Mobile phones, and the phone we can have that you put your fingerprint in, your laptop that we have, maybe the keyboard, in order to do the authentication from one to the other. I was looking at, the biometrics, where are they going to be read? And we have the fingerprint reader, the retinal scanner, whatever we have. The hardware may have these biometrics enabled, and you probably may have a phone. I have an old phone. You may have a phone that has a fingerprint scanner. You may have a laptop that has a fingerprint scanner. What they normally will do, except the phone that we just got didn't, but normally we'll do is have you scan more than one finger, because what happens if you cut it and you now have a scar on it? What happens if you burn it and it's no longer recognizable? You need to be able to do that. You also probably want to have a secondary. If you're unable to use it, what are we going to do? Digital certificates we've looked at a little bit already, signed by a certificate authority, and that's what I wanted to show with this. This is the certificate store on this computer. It is signed by, they are signed by a certificate authority, and we have the Trusted Root certification authorities here. These are the Trusted Root certificate authorities, the certification authorities, a firm on down the line, Entrust, GoDaddy, and let's see if Comodo is right here, certificate authority. When we look at their certificates, and I can't make these any bigger, allows data to be signed on down the line. It's got a whole list of functionality for these things. Comodo, issued by Comodo Certificate Authority 12/31/2010 to 2030. That's a long time. That's 20 years for a certificate. And when we look at the certification path, they signed it themselves. But because the certificate is okay, but because they are listed as a certification authority, that's okay. A self-signed certificate. We can issue self-signed certificates, but nobody's going to trust it. That's one that's going to show up and say, hey, there's something wrong with her. When you get the pop-up that says something wrong with this certificate, the reason that it pops up is because there's something wrong with that certificate. Could be something simple like it expired yesterday. If it's an expired certificate, it still works. It's just that it's not valid based on all of the information that's in it. It could be a situation that it's issued to a particular website and you went to the IP address. They don't match. Then it's going to be an invalid certificate. They get pretty particular about these things. And you can look over here, the expiration dates, and they are a long way out. Here's one that actually 2031, 29, 26, 37, 29, 2018. So this one should, and it shows up as certificate information, that it is no longer valid. So if we have certificates that were signed by this certificate authority, and what I'm talking about with that, let's go back to this one because it was actually signed by the Sectigo here bought Comodo. and then the Komodo RSA client, the certificate authority and the issuing authority when we do those things. Typically the certificate authority, the root certificate authority doesn't stay online. So they are signed certificates, and we can view the certificate, each of those that we want if we want. A certificate authority signed by a certificate authority, or self-signed. If we have self-signed, and government uses, or used to use at least, self-signed certificates because they got a tremendous number of secure websites, HTTPS. You can install their root certificate in your root certificate store, and then you don't have the pop-up that said, hey, this is something wrong with the certificate, it's invalid. It now, as part of the store, will say, okay, it's okay, I can now authenticate that certificate. Internal local area networks, Active Directory, you can use the self-signed certificates. Users will see certificate errors in their browsers because it's not from a trusted certificate authority. It's by us, and we can then issue or put it in the certificate store. Certificate authority signed certificates for the network that has WAN links when we want to go someplace. When a web site wants us to be able to go there, we're going to do that. The certificate authority signs and revokes certificates. They got to show themselves, CS show themselves trustworthy. I think probably 2 years ago now, there was a certificate authority that got compromised. When a certificate authority gets compromised, all of the certificates that had been issued by it are now invalid. So, and they eventually went out of business, probably about 8 months after the compromise, because nobody was trusting them. The Iranians had compromised it, gotten the root authority, and they were issuing certificates to anybody that they wanted to. Root certificates, out-of-bound distribution. We don't really want these servers or this root transfer to happen online. And out-of-band just means that we're going to use some other method. In the configuration world, the in-band would be when we would telnet. Out-of-band might be if we used a modem when we do that. Something different in order to be able to try to hide what goes on for these things. The certificates, we have limited purpose, multi-domain, wildcard, and extended validation. Extended validation means that they've done a little bit better, a lot better job, or you have had to go and do a whole lot more proving that you are who you say you are. I want to try to look at a couple of these things if my browser will work here. You can go, when we go to an HTTPS, and this is ECPI, the reason I want to do it is it's going to have the multi-domain capability in here. If I look at it, view the site information, the secure website, certificate is valid. When I go to the details of the certificate, I was going to make that go away, but I can't. Valid from subject alternative names. It is issued to an organization, but these are all of the other names that can be used or that it can be used for. When I said that may show up with an issue, if it's on one of these sites, then we're okay for this thing. They at one time had a wildcard, and a wildcard mask will just say star dot whatever where it's issued to. Issuer, Lesscrypt authority, and these are one that I don't even know who they are. The subject here is this. The common name is this site, would be the initial one, .io, and then all of the other ones, the certificate. The subject alternative sites are available for it. If I go to just quickly learning, if we can get there, HTTPS, learning your question online, they had an issue earlier this year. The certificate expired. Certificate for this thing is valid. Ensure identity of a remote computer. proves your identity to a remote computer, and the other things that it's responsible for. Issued to MSAN5.myabsorb.com. That's going to be the final learning or the final destination. If we look in DNS for this thing, then this is going to be probably a C name that we talked about, a canonical name that we do, 2/9/2020 to 4/9/2021. This one actually had expired earlier this year. Absorb.com, even though we go to learning.leaderquestonline.com, the actual address that we're going to is Absorb when we look at these things. And the valued, let's see, the subject is the IP address, or not the IP address, the name of this site, msn5.myabsorb.com. It's not going to have any subject alternative. Actually, it does too. It's got subject alternative names also, so that this can be used on these domains as well. And if you look at this, if you ever want to know where these guys are, they're in Calgary, Alberta, Canada. Tells us where things are, the validity, the information about what goes on with them. So multi-domain, wildcard, extended validation. Extended validation used to change color. The extended validation ones would turn green when you went there. I haven't noticed that happening lately, but extended validation just means that the certificate authority or the issuing authority has done a more extensive investigation to be sure that you're who you claim to be. Certificate authorities, we can have a single certificate authority or a group of certificate authorities, the parent or the child. At some point, we're going to have a certificate that is self-signed by the root, the entire root, and then the child certificates would be signed by the root. The child would sign the issuer, and on down the line, the issuer would sign the ones that go to us. But you have to have a valid chain, a chain of custody, a chain of validity is what we're going to have with these things. Each certificate authority works in a parent-child relationship with the CAs above it, ensures that that we distribute the workload, and provide certificates more efficiently. And also, if one of these guys gets compromised, it's going to have a different certificate that it assigns, and it signs the issuing certificates with, or the issuing authority with. So there's going to be fewer of them that are compromised if it gets compromised. If a certificate authority is compromised, only its children are compromised as well when we do that. If the root gets compromised, then everything that's been issued down the entire chain is going to be compromised with these. The chain of trust, we've seen that in a couple of certificates, may be signed by another certificate authority, which is signed by another certificate authority above it. And the entity must trust all of the links in the chain. So I'll go back to this expired one here. We have a Certigo, a Comodo RSA client, and then we have a Me. And this would be, and Me is expired, so it's no longer valid with the red access for. That's one that would say, hey, there's something wrong with this. So if I go into, and let's see if we can show some of this stuff. Let's go into the trusted root certificates. I'll have one at a time. Let's see if Certigo is here. And these certificates, go down here, HIJKLMN, and it probably won't be, but Certigo isn't here. They are new. Comodo was the one that it is here. That's kind of interesting that it's not any of these. These are going to be the issuing of Certigo on any of them. Yeah, there it is. Ah, we found it. So it is in the trust here in the intermediate certification authorities. And then under it, we had the RSA. So we have to trust everything that's in that chain. It has to be in our list of certificates, which didn't used to be nearly as big as they are now. If you ever want to look at it, you just go look at the Cert Manager in the Windows system, and you can see that. You probably can, and I haven't looked at Edge or well, you can in Chrome. I know you're probably going to be able to see them through the through the browser, because those are the things that are going to be using them predominantly, whether it's a secure site or not a secure site. The topmost CA in the hierarchy is going to be the most trusted. Self-signs its certificate, got to be secure. If compromised, all the other certificates are invalid. Things that we looked at, talked about while we were doing these things. Any CO that's below the root in the hierarchy, the subordinate certificate authorities, they're going to be the one that issue the certificates. The root CA is just going to sign the certificates for the subordinates, for the issuing authorities. They're then going to sign, and we'll have the root and the signing authority on down the line are all going to be in the chain of trust that we have on the certificate itself. Renew, suspend, and revoke certificates. The difference between suspend and revoke is suspend as we temporarily make it invalid. It gets suspended, it can be re-enabled. If it is revoked, it's gone forever. It can't be reused again. So suspend, temporary, revoke, permanent.